Hello class. In this lecture I will talk about hypothesis testing for two population means using Zstat, and I will solve a one-tail problem. So the question is an analyst wants to know whether the weight of people of Killeen is greater than the weight of people in Harker Heights. The mean weight of 64 people sampled in Killeen is 164 pounds, and the weight of 50 people sampled in Harker Heights is 166 pounds. Assume that the population variance is known for Killeen and Harker Heights. The population variance for Killeen is 9 and the population variance for Harker Heights is 16. Is there enough evidence to claim that the weight of the people in Killeen is greater than the weight of people in Harker Heights at 99% confidence interval? So to do hypothesis testing, the first step of hypothesis testing is to define hypothesis. So you have your null hypothesis, and then you have alternative, and then an analyst wants to know whether the weight of people in Killeen is greater than the weight of people in Harker Heights. And then there is another area where they talk about this. Is there enough evidence to claim that the weight of people of Killeen is greater than the weight of people of Harker Heights? So Killeen, I will consider the population mean to be mu1, and for Harker Heights I will consider it to be mu2. So when they claim the weight of people in Killeen is greater than the weight of people in Harker Heights, it's an alternative mu1 greater than mu2. So our null hypothesis would be mu1 less than or equal to mu2. So always remember, in null hypothesis you will have equal. So this can also be written as mu1 minus mu2 less than or equal to 0, and the alternative would be mu1 minus mu2 greater than 0. So to analyze that, the analyst has done a sampling in Killeen and Harker Heights. So this data is given. So the mean weight of 64 people sampled, so N1. So this is for Killeen and this is Harker Heights. We have N1, 64 people sampled in Killeen, so N1 is 64, and the sample mean is x1 bar is 164, and then the mean weight of 50 people sampled in Harker Heights, so N2 is 50, and then x2 bar is 166, and then assume that the population variance is known. So sigma 1 square and sigma 2 square are known. So the population variance for Killeen is 9, so this is 9, and then for Harker Heights it is 16, and then we wanted to calculate 99% confidence interval. So this means alpha is 0.01. So you do to get alpha 1 minus 0.99, that would be 0.01. So we have all this given. So the next step in hypothesis testing is to compare test statistic with critical value. So the first thing is we wanted to determine whether it is a Zstat or a Tstat. So to do that, we know, we see our sample size n1. So this is n greater than 30, 64 is greater than 30, and n2, this is also so this is n1, n2 greater than 30, both are greater than 30, and your variance sigma 1 square and sigma 2 square, which are population variance, are known. So this means you will be using z-test, z-stat. So the test statistic, again I will be using z formula. Z is equal to x1 bar minus x2 bar minus mu1 minus mu2 over square root of sigma 1 square by n1 plus sigma 2 square by n2. So I will substitute these values. X1 bar is 164 minus x2 bar is 166 minus mu1 minus mu2 will come from H null, so that is equivalent to 0. So I will do this 0, and then sigma 1 square is 9 divided by n1 is 64 plus sigma 2 square is 16 over n2 is 50. So this is going to give us z is equal to, the numerator would be negative 2 and the denominator would be 0.2678694. So this is going to be negative 2.94. This is same as what we did in two-tail. However, if you wanted to now you want to calculate the critical value, so this is for a two-tail problem, it was z alpha over 2, that is what we did, two-tail. Now this is a one-tail problem. You see, the one-tail is because we have one side less than or equal to. So if it is exactly equal to, then it is two-tail. If we have less than or equal to or greater than or equal to, it's a one-tail problem. So the critical value we know, because it has less than or equal to in H null, it's a one-tail problem. So we wanted to calculate z alpha. So alpha, for alpha they gave 99% confidence interval, that is what is given. If you look at our 99 and we calculated alpha, which is 0.01, so they gave us, so you do 1 minus 0.99, that is equivalent to 0.01. This is our alpha. So z at probability 0.01 is what we are looking for. So what is this value? So I will show this how it looks in normal curve. So this is, again, this curve represents H null. So this is mu1 minus mu2 is equal to 0. So our H null, what does it say? It says mu1 minus mu2 less than or equal to 0. So our H null is mu1 minus mu2 less than or equal to 0. So we have certain z value below which this area, so this entire area is maybe 0.99, and this area is less than certain value. So this is where you do not reject null hypothesis. So this is where mu1 minus mu2 will be less than or equal to 0. So that will be mu1 will be less than or equal to mu2. So this area which I am showing you currently is the area where Killian's height will be less than Harker heights. So that is our H null, and then this area is reject H null. So when I do reject H null, H alternative becomes true. So that means mu1 minus mu2 is greater than 0. So our H alternative is mu1 minus mu2 greater than 0. So this means mu1 is greater than mu2. That means Killian height is, Killian's weight is greater than Harker height's weight. So I wanted to know what is this point. So this area is 0.01. This is alpha. So this area, if I wanted to calculate z 0.01, if I come from this side, if I see from this side of the curve, from the left side of the curve, it will be z at 0.99. So since our z curve, z table gives left side of the curve, I will look for z at probability 0.99. So this is probability. So now I'm going to go to our statistical tables and look for z value at 0.99. So I will go to our Canvas page, go to modules, go to module 0, look for calculation aids, and then download statistical tables and open this. Do enable editing. I am currently in Poisson table. I will go to Z table and look for 0.99. So 0.99 is somewhere here or here, 2.32 or 2.33. So this is 2.33 and 32. So I will take 2.32. So this is 2.32. So this value here is 2.32. So this one is 2.32. So now I go and look at, maybe I will use a different color, and then I will go and look at the z test statistic value. It is negative 2.94. So I will go and look for where does, since this is 2.32, what side of 2.32 does my negative 2.94 lie. So negative 2.94 would be somewhere here to the left of 2.32. So that falls under do not reject H null. So that means I'm saying this is true. So that means the weight of people in Killeen is less than the weight of people in Harker Heights. So again, weight of Killeen, people in Killeen is less than Harker Heights. So the question says, is there enough evidence to claim that the weight of the people of Killeen is greater than the weight of people in Harker Heights at 99? In fact, Killeen is less than, so we don't have enough evidence. So there is insufficient evidence. There is insufficient. This is the conclusion I'm making. Insufficient evidence to claim that the weight of people in Killeen is greater than Harker Heights. So this is at 99% confidence interval. So that's your conclusion. So now we can solve the same problem using calculation aids. So I will go to our calculation aids and try to solve this problem. So I will note down all the given stuff along with hypothesis. So I'm going to note down everything from here to here. So H null is mu1 less than or equal to mu2. So our null hypothesis would be mu1 less than or equal to mu2. Our alternative would be mu1 greater than mu2, and then given is n1 is equal to 64. So this is Killeen data, and then x1 bar is equal to 164. Sigma 1 square is given as 9, and then Harker Heights data n2 is equal to 50, x2 is bar is equal to 166, and sigma 2 square is 16, and then and then let me write the confidence interval. So confidence interval is 99%. So now I will download our calculation aids and try to solve this problem. Again, I am going to our modules, and then module 0, and I will go to calculation aids, and chapter 11 calculation aids, and I will do enable editing. Again, which sheet to use: known variance, unknown variance, mean, paid or proportion, which spreadsheet to use. So I will go here, and since I have sigma 1 square and sigma 2 square both are known, these are population, variances are known, I will use known variance sheet. So again, this is, we are using Zstat because n is greater than 30 and 64 is greater than 30, and n2 is, so this is n1, n2 is 50, which is greater than 30. So I will go to known variance sheet and try to type in the values. So sample 1, let me go and see what are my sample 1 sample mean. So the sample mean is 164, so I will type in 164 164 and then population standard deviation, this is so what is population standard deviation? This is sigma 1 square is given, which is population variance, so sigma 1 square is 9, so population standard deviation would be square root of 9, which is going to give me 3. So I will type in 3 here, and then the sample size is given as 64, so I will type in 64, and then I will go to sample 2, the mean, I'm looking for sample mean, that is 166. I will type 166, and then sample standard deviation, not sample standard deviation, population standard deviation. So sigma 2 square is given as 16, so sigma 2 would be square root of 16, which is 4. So I will go here and then type in 4, and then sample size, I think it's let me go and check. So the sample size is 50, so this is 50, and then alpha is they gave us 99% confidence interval, so 1 minus 0.99 will be our alpha, so that is going to give us an alpha of 0.01. So I go here and type in alpha of 0.01. So now if you see, we have our test statistic value, which is negative 2.94. Now which case to use? Case 1, case 2, case 3. Mu1 minus mu2 not. This is a two-tail problem, so we will eliminate this. Let's look at H alternative values. This is H alternative mu1 minus mu2 greater than, and this is H alternative mu1 minus mu2 less than. So here I am looking at my alternative. So this one, H alternative, so this can be written as mu1 minus mu2 greater than 0. So that means it is greater than. So I will go and look at. So if you see, mu1 minus mu2 greater than is this one, so I will be using case 1. So my critical value is 2.32 and my decision would be don't reject. So that will be the decision. So this means don't reject H null, that is what they are saying. So I'll go here. That means our answer would be don't reject H null. Don't reject H null. So H null is true. That means mu1 minus, okay, H null is true. That means mu1 less than mu2 is true. That means the height of, not the height, the weight of people in Killeen is less than the weight of people in Harker Heights. This concludes my lecture on one-tail problem hypothesis testing for two population means Zstat. Thank you.